Okay, this is chapter 1, course division. Um, Basically, we have these questions. Which of the following systems constitute steady state situations and which are at equilibrium? Okay, and for each, a constant property is indicated. An unopened bottle of sparkling water. I think this is steady equilibrium. Yeah, it's at equilibrium because the pressure is constant, the volume is constant, everything is constant when it's unopened, right? A Bunsen lit with a constant bloom flake color. Here, it's still increasing the temperature, right? You're lighting the Bunsen. So we just call it steady state, and it's just the reactions occurring. What's the difference between equilibrium and steady state? Equilibrium means all the just more. What are they called? Some property. It's called like um macroscopic. All macroscopic properties are constant. But steady state means the macroscopic properties are still changing, but at a constant rate. Do you get what I mean? When the Bunsen burner is lit, it's still increasing the temperature. Okay, even though the color is constant, I don't care, أخي, but it's a steady state. But here, on an open bottle of sparkling water, the pressure is still constant, the volume is still constant, the density is still constant. This is called equilibrium. Okay, when you open it, بعدين everything opens, everything changes. What happens when a system reaches equilibrium? What this is a great question, comes every exam. When a system reaches equilibrium, the concentrations of reactants and products are constant, right? And the rate of the forward is equal to the rate of the backward. Memorize. Okay? Predict what would happen to equilibrium concentrations of water and H2 if the partial pressure is increased by injecting more O2 into the reaction chamber at 273 degrees Celsius. Okay, you're increasing O2, increasing the concentration of O2. What's gonna happen? They want to decrease O2. So what's it gonna go? It's gonna go to the left, right? It increases O2, so it wants to decrease O2. The system will oppose it by decreasing O2, so it's gonna go to the left side. Okay. So what would happen to the concentration of H2O? It will increase. H2 will decrease. Yeah, that's it. For part B, after the equilibrium represented above is established, some pure. Wait, let me just make sure for part A. The system wants to decrease O2, so it goes to the left. Okay, yeah, whatever. Okay. After the equilibrium represented is established, some pure SO2 is injected into the reaction vessel at a constant temperature. Which of the following has a lower value compared to a syringe? So basically, what happens? You increase SO2, so what will the system do? It will decrease SO2. So what's it gonna go? It's gonna move to the left. So SO3 will increase. So which of the following is lower? They're saying which is gonna be lower? It's gonna be O2 because it's going to the left, so O2 will be decreasing. So the amount of O2 will be lower, right? The chromate and dichromate ions are set up in equilibrium as follows. How many questions do we have? 1 to 946. Okay. What happens in each of the following cases? Complete the table below. If you increase H plus, equilibrium shifts to where? Increase H plus is going to shift to the right. Color change. Going to the right, so darker orange. Change to CR2O7 to minus. You're going to the right, so obviously increase. It increases. They're saying concentration because these square brackets mean concentration. So what happens to concentration of CR2O7? It's going to increase. Increases CrO4. Increases the CrO4. Same thing as H was because they're on the same side. Okay. So right. Color change darker orange. And the concentration of the product will increase. Let me just double check this. Right, orange increases. Yeah, just don't say darker, just say orange because it's orange here. Okay, decrease in H plus is gonna be the opposite of increasing H plus, so it's gonna go left. It's gonna be yellow because it's going to the back. Over here, yellow. Okay, and the change of CR2O7, since you're decreasing H plus, is gonna move to the left, right? So it's gonna decrease CR2O7. Add NaOH. If you add NaOH, you're adding a base. Okay, a base has low H plus, if I'm not wrong. So it should be the same as the one above it. I just need to make sure. Yes. Okay. NaOH is a base. You guys, bases have OH. Do they have H plus? No, they have OH. So it's removing H plus. So what's gonna happen is the same as the one before. So left, yellow goes down. Adding HCl. HCl is an acid, so it has H plus. So it's the same as the first one. Okay. So it's gonna go right, orange, and increases. Okay. Predict what will happen to the equilibrium concentration of CO2 if some CaCO3 is added to the system. CaCO3. When you add CaCO3, it wants to decrease CaCO3, so it's going to move to the right. So what will happen to concentration of CO2? It will increase. You add CaCO3, it wants to oppose it, so it's going to decrease, so it's going to move to the right, so CO2 will increase. Predict what would happen to equilibrium concentration of H2O and H2 respectively if the pressure at 273. Let me just check the answer for part D, right? Oh wait, why does it not change? Oh, saw. Yes. Because CaCO3 solid is added to the system. You can only increase the concentration of gases and aqueous solutions. You can't increase concentrations of solids. So when you add a solid, nothing will happen, okay? That's a trick question, guys. Pay attention to these. Okay. Predict what would happen to the equilibrium concentration of H2O and H2 respectively if the pressure is increased by adding unreactive He. Adding an inert gas, what's going to happen? Nothing would happen. So part F, the equilibrium system represented below, is contained in a sealed rigid vessel, 4HCl plus O2 to produce 2H2O, whatever. What will happen if... So which of the following will decrease if temperature is increased? So if you increase temperature, what's going to happen? It's an endothermic reaction. Wait, no. It's an exothermic because delta H is negative, right? So the forward is exo. You know, when you increase temperature, it wants to decrease the temperature. It favors the endothermic side, right? In this case, the forward is exo. So if I want to go endo, where do I go? برجع لورا, I go backward, okay? I'm going to go backward. So what's going to decrease? H2O and Cl2. So I guess it would just be this one. Uh, that's it, I guess. The third one. Yeah, the products decrease, yeah. Yeah, Cl2. Okay, yes. Okay. Consider the following system. State the effect of adding a catalyst to the system on the position of equilibrium. If you add a catalyst, it will not change the position of equilibrium, but it will only increase the rate, right? It does not affect the position of equilibrium. Catalyst does not, it only increases the rate. Yield can be defined as the amount of product formed by a reaction. How can you increase the yield of ammonia production? Ammonia is produced by combining nitrogen and hydrogen gas as well. If you want to increase the products, what can you do? You can either maybe increase concentration of hydrogen, you can increase concentration of nitrogen, maybe you can increase the pressure, because if you increase the pressure, it will move towards the right, less gaseous modes. All of these are correct answers. Let me check what they have. To maximize the yield, we want the reaction to proceed to the right. Okay. Temperature. Oh, wow. That's a lot. Okay, yeah. So I guess we could say delta H is negative, by the way, and it's exothermic. So what they would do is they would decrease the temperature, right? Because it's exo, and they would increase the pressure. If they decrease temperature, it will favor the increase in temperature. It will favor the exo, so it will favor the forward of ammonia. If you increase the pressure, it will want to decrease the pressure, so it goes to the less gaseous mode, so it will favor the forward, which is also ammonia. So these two things are important. I guess they yapped a lot here, but you should know. We don't ask these questions, but this is to do with the Haber process. It came in our written, guys. Here, F5, Fe3 plus SCN minus FeSCN, or whatever. What would happen if you removed Fe? If you removed Fe, the equilibrium will shift. Obviously, it will want to increase Fe. Removing Fe, it will want to increase Fe, so it's going to move to the left to increase Fe, to the left. And what will happen to FeSCN? To plus this stuff here, it's going to decrease because you're going to the left. Addition of SCN minus. If you increase SCN, it will want to decrease the system will want to do the opposite and decrease it. So it's going to move away from it and it's going to go to the right. So it will increase FeSCN. Fill in, is it correct? Left, right, decrease, increase. Fill in the table to determine the effect of increasing pressure on the given systems. Okay, if you increase pressure, equilibrium will shift where? It will not change. Why? An increase in pressure will shift to less gaseous modes. Here you have 2, here you have 2, so it will not change. Why 2? Because 1, 1, and then 2. So there's 2 on both sides, so not change. Amount of products, again, no change. Okay, here you have 1, you have 2 and 1, so you have 3 on the left. Here you have 2. If you increase pressure, it's going to move towards less gaseous mode, so it's going to move forward. And what's going to happen to the products? It's going to increase because you're going forward. Increase. Okay, here you have 2, here you have 4. Obviously, increase will move towards less gaseous mode, so it's going to move to the left. We're talking about increase in pressure. So what will happen to product? It will decrease. Using Le Chatelier's principle to predict the effect of whatever. Okay, predict the effect of increase in temperature. Okay, if you increase temperature, here the reaction is exothermic. So what's going to happen if you increase temperature? Let's put on the side. If you increase temperature, the system will want to decrease, so it will favor the endo side. Here, the forward is what? Endo or exo? It's exo. So will it follow the forward? No, it will go, let's say, left or backward. And what will happen to the concentration of the products? It will decrease. Here, the reaction is endothermic. Now we want the endothermic side because we said it's going to favor the endothermic side, right? We want the endothermic side, so we're actually going to, the forward is endo. Even though they put the energy in the left, it doesn't mean that the backward is endo. It means the forward is endo. Okay, so since we're following the endo side and the forward is endo, that means it's going to favor the forward, or it's going to shift to the right. What's going to happen if it goes to the right or forward? It's going to increase product. Here, delta H is negative, so it's an exo. So will it favor the forward exo? No, we want endo, so it's going to go backwards. So products will decrease. Very easy, guys. Nothing too hard. Question 8 and 9. Using a chatelier to predict the effect of addition of catalyst. Okay, what happens if you add the catalyst here? Nothing will happen to the equilibrium. Nothing, right? Let me check. Okay, this one. Yeah, okay, we got this. Yeah, catalyst increases the rate, but it doesn't affect the equilibrium, right? So it doesn't increase yield, but it only increases the rate. Using the Chatelier's principle, inert gas, nothing happens, right? It doesn't affect. So for catalyst, rate increases, but yield stays the same, equilibrium stays the same. But for inert, nothing happens. Okay. Then they said what? 14 to 16. I think we can do them fast. Oh my god, I hate these questions. 7 parts, man. Okay, the graph below shows the yield. Okay, which of the following reactions is represented in the graph? So, when you increase pressure, the yield doesn't change. What does this mean? That means that the gaseous moles is equal on both sides, right? Because remember, pressure would change the yield towards the less gaseous moles. Since it didn't change, that means both sides have the same amount of gaseous moles. Here I have 4, here I have 2. So this is wrong. We need them to be the same. Here I have 2, here I have 3. So this is wrong. They have to be the same. Here I have no gas here. Here I have 2. So again, that would be wrong. Here N2O2, 2. So I have 2 here and 2 here. So this might be correct, but let me check the last one. Yeah, it should be D. Okay, but let's double check. As we increase the temperature, we're going to the right, the yield decreases. You know, when you increase in temperature, the system will want to decrease it, so it's going to favor endo, right? But we're decreasing the yield, right? So that means we're going backwards. So that means the backwards is endo, okay? You want to increase temperature. If you increase temperature, system will decrease temperature. It's going to favor endo. In this case, the system, is it favoring the backward or the forward? If it's going down, it's favoring the backward. That means the backward is endo. That means the forward is what? Exo. Forward is exo. And let's check here. Is our forward exo? Yes, it is. Because delta H is negative. So it should be part D. 14. D. Okay. Question 15. We'll do this fast. Carbon dioxide and hydrogen gases react at 75 and 250 to produce methyl alcohol industrially. CO plus 2H2 to produce CH3OH, and the backward reaction is endothermic. They told you backward is endo, so forward is exo. Write a source of hydrogen for this industrial process. Always, anytime they say source of hydrogen, you say methane. Okay, if I'm not wrong. 5A, methane. Okay. Complete the table using the words decrease, increase, or no change. If you increase the pressure, it's going to move towards less gaseous modes. So it's going to stay here. No, here you have 3 gaseous modes, 1 and 2. We'll get you 3. Here you have 1. So it's going to move towards effect on the rate of the forward. It's going to move to the forward, right? So it's going to increase. Okay, I'll just put effect on the equilibrium yield of CH3OH. If it's going forward, what's going to happen? It's going to increase. Decreasing temperature. If you decrease temperature, it's going to want to increase temperature. So it's going to move towards the exo side. In this case, we said that the forward is exo because the backward is endo, the forward is exo. So it's going to move towards the forward, so increase the forward, and which would therefore increase the yield, right? Adding a catalyst, effect on the rate, it increases, but on the yield, no change. صح? So it should be like this. Yes. Decreases. Effect on the rate. They meant rate. Of course, yeah. Decreasing temperature would decrease the rate. Yes. Bromine and hydrogen gases react together in a reversible reaction. Hydrogen bromide is formed. The forward reaction is exo, a gas syringe containing equilibrium. Okay, whatever. What is meant by the term equilibrium? The term equilibrium means the concentration of the reaction and product. The concentrations are constant and the rates are equal. Memorize it like this. Okay, what does equilibrium mean? Concentrations stay constant, rates are equal. As the syringe plunger was pressed while keeping the other end blocked, the pressure increased. It was shown that the position of the equilibrium did not change. The color of the gaseous mixture turned darker brown. Give a reason why the position did not change. Why would why would it not change? Because you have one here, so you have two gaseous moles on the left and two on the right. So that means what anytime you increase pressure and the equilibrium doesn't change because same number of gaseous moles. Because remember that when you change pressure, it will move. If you increase pressure, it will move towards less gaseous moles. Suggest why the gaseous mixture turned darker brown, even though the position of the equilibrium did not change. Voila, that's a good. I actually don't know. I think maybe because there's less volume. Yeah. Okay. Yeah. So enter when you're pressing into the syringe, you're closing it. أول شيء there's less pressure, the HBr, the gases, it's spread around in as the BR, it's spread around in the syringe. But when you pressure it, when you close it, there's less space for the gases, so they're gonna be mixed together, mixed together. So there's gonna be more brown gas. Okay, you guys know C is equal to N over V. If you decrease the volume, then the concentration will increase, and therefore you're gonna have a darker brown color. Okay. Uh, Thank you to Jamil Ahmed for helping me out with that one. I wouldn't have known it without them. So just why the gaseous mixture turned darker brown, we did that. Okay. Part C. The temperature of the gas range was increased to 400 degrees Celsius. What happens to the position of the equilibrium when the temperature of the gas range was increased from 250 to 400? Okay, if you're increasing temperature, this is reversible. They said that the forward is exo. Okay, the forward is exo. If we increase the temperature now, the system will want to decrease the temperature, right? It will want to decrease temperature, and therefore it will favor the endothermic side. If the forward is exo, then since we're favoring the endothermic, we want to favor the backward side, right? So what's gonna happen to the position of the equilibrium? It will shift to the left, or you can say it shifts to the backward. Okay. Let's see. It will shift towards the left. Okay. What happens to the rate of the forward reaction and the rate of the backward reaction when the temperature was increased? They're saying rate. Rate. We don't care about yield. When you increase temperature, what happens to the rate? Increase. Increase. Okay. That's it for chapter 1, course division. Thank you so much for watching and good luck.